Hello and welcome back to E-Times Live coverage from the San Diego Convention Center, San Diego, California, of the 48th Design Automation Conference. I'm Brian Fuller, Editorial Director with E-Times' EE Life section. And we're here with old friend, a longtime E-Times contributor and founder of BDTI, Jeff Bier. If you'll recall, we've been following our either archived or live coverage from Embedded Systems Conference last month. We had Jeff on to talk about embedded computer vision, and he promised at the time that he would meet with us again here in San Diego, and he brought some toys with him. Welcome.
Thanks a lot, Brian. Good to see you.
Good to see you. So we're going to do something kind of without a net, I guess, and I'm going to let you tee that up, but I have to say this is probably the most interesting segment we've done in the last 3 days.
Good, glad to hear it. Yeah, so when we talked at the Embedded Systems Conference, I was telling you about this notion of embedded computer vision, machines that see through visual inputs. Computer vision's been around for decades, but it's been mainly relegated to a few kind of hidden niche applications, things like factory automation and aerospace equipment, where they can afford very powerful, very expensive hardware. We're at a transition point now where computer vision is coming into the mass market. Mm-hmm. It's becoming possible because of increasingly powerful processors to implement really quite sophisticated computer vision capabilities at price points that makes it practical to use them in consumer products, in cars, in video games, in all kinds of things. So we've just a few weeks ago announced the formation of the Embedded Vision Alliance,
right.
which is an industry association dedicated to really getting the word out and helping engineers get the practical technical know-how that they need to understand what the technology is capable of and how to go about incorporating it into their products.
Okay, and so you have demo.
Yeah, so let's have a little sort of A-B comparison here.
Okay.
Show me how you present a PowerPoint presentation on your laptop. So you're back at the office, got to make a presentation to the boss, you're standing up in front of the room, you've got your laptop. What do you do?
So what you do is, obviously you fire up the application, right? It's usually PowerPoint.
Yeah.
If you've planned it properly and you're smart enough, you've plugged it into like an overhead projector.
Yes.
Okay, so you fire up the PowerPoint, you've plugged it in, you've got everything powered on, and then you look at your keyboard and you try to figure out how the hell to get the computer to send the signal to the overhead thing, while the boss who's going to be doing your review in 6 months is causing you to sweat down the back of your neck. So that's usually how it does. And then, assuming you figure that out, then you just sort of manually click through these boring slides.
Well, they're your slides, so they're very engaging and dynamic. And in fact, you're up in front of the screen and you are passionate about it, but then every minute or so you got to lean over, find the right button to advance the slides.
Correct.
Right? That's very 2009. That's not how we do things anymore.
Okay.
We don't, no. So this is, what I'm going to demo here is the Microsoft Kinect, which you may have heard about. So This is a peripheral for the Xbox 360 game console. And it's a computer vision based peripheral. So it allows users to interact with the video game by moving their bodies. And it's also been adapted for a number of other purposes. In fact, one of the most amazing things about the Kinect is just how in a few months, hundreds and hundreds of people have adapted to all kinds of interesting ideas. It's really unleashed, I think, a lot of creativity among engineers. So in this particular case, I've got the Kinect hooked up to my laptop, and I've got a piece of software that allows me to control my PowerPoint presentations through gestures. So I can be up in front of the room, I can have the cameras in the Kinect watching me, and I don't need to reach over and find my laptop and find the right button to advance the slides. I can just make the right gestures in front of the camera, and it will automatically respond accordingly. Open, close, forward, back, what have you. So let me stand over here in front of it. You can see what I'm talking about. So here's the slide deck I want to show, and I hold my hand over it to open it. And then I'll scroll to the first slide, hold my hand over that to open that. There's my first slide. Whoops, closed it by accident. So there's my first slide. Now when I want to advance, I simply do this. Simply wave my hand in front of the camera and say, yeah, next slide. Or if I want to go back, I do it the opposite way, and it goes back. If I want to close the file, I either make a downward gesture or hold my hand over the X. I can also use two hands to zoom. So if I move my hands apart, that's zoom in, move my hands together, zoom out. Once I'm zoomed in, I can also pan around by moving my hands.
Wow.
So, this is not the smoothest implementation of this idea. This is, I think, still a prototype, but it gives you an idea. This is how it's going to be, right? You're not even going to need the laptop, you're not even going to need the keyboard. You'll have your tablet or even your smartphone. You'll go into the presentation, you'll plug into the projector, you'll point the camera or cameras on your portable device up at the front of the room where you're standing, and then you'll be able to control your presentation, in this kind of gesture-based way without having to futz with the screen or the keyboard or what have you.
So if you're Italian, this is fantastic.
Well, it can actually be a problem, because if you're prone to gesturing while you talk, you see what's happening here. I'm gesturing with no particular intent of controlling the thing, but it's going haywire. This particular software, the way they've implemented the gesture controls, they have a safe zone. This piece of software is called So Touch Presenter. It's made by a company in the UK and France, and what they've done is define a safe zone. So if your hands are within 30 centimeters or so of your torso, then it assumes you're just gesturing to express yourself. You're not trying to control the system. But once you move your hand, see what happens here? That blue dot shows up. So once I move my hand about 30 or 40 centimeters away from my torso, then it says, okay, now I understand you're trying to get my attention. And so the blue dot indicates that it's tracking, and a swipe gesture means advance the slides or go back, depending on whether it's right to left or left to right. Two hands held up together means zoom. If I pull them apart, I zoom in, put them together, zoom out, move them both in unison, and it pans. And then once I put my hands back near my body, it says, okay, you've disengaged now. So, this is a pretty simple concept, but I think it illustrates some very exciting ideas. One is that with computer vision, we can add computer vision to all kinds of existing products and make them more usable. And especially with respect to user interfaces, we have all these incredibly powerful machines that we use, but they're by and large really hard to use. Even to the point of you sit down in a typical living room in front of a television set and you have an array of 5 remote controls, 5 handheld remote controls, each with like 50 buttons, each with all kinds of cryptic labels on the buttons. When I'm visiting, my brother's house, I can't figure out how to turn the TV on, right? It's a very machine-centric way of interacting. These 5 remote controls with lots of little buttons labeled cryptically. A much more human-centered way is, well, let me talk to the machine, let me gesture at the machine. Higher volume, next channel, whatever, mute. Make it a more human-centered kind of experience and make it much easier in that way for people to use their electronics. We're getting to the point now where it's becoming feasible to integrate this kind of capability into lots of different kinds of products because it's getting to be less and less expensive to do so. For example, the Kinect, Microsoft sells that. I think the retail is about $130, which includes a game title. Teardown, I think, showed the bill of materials cost was under $60. Now, the Kinect itself isn't a self-contained solution. It plugs into the game console and uses some of the processing power in the game console, or in this case, some of the processing power in the laptop. But I think still, it's a really tantalizing indication of things to come. And in fact, thousands of Kinect units are being used by engineers in their garages, in university labs, in industry labs to experiment with all kinds of really cool computer vision concepts.
Yeah, that is just fascinating, and it's sort of, I mean, maybe Microsoft anticipated something like this, but it's sort of, and I don't mean to misuse this phrase, but it sort of has a whiff of the whole open source movement. In other words, something is put out in the public domain and catches fire. Now, open source is completely different, but here, something has been put out in the domain that perhaps nobody anticipated would cause such innovation.
Yeah, well, I think I give Microsoft huge credit for for the Kinect concept and the execution. I think it's a great concept, and I think it's very well executed. But it's clear that what Microsoft had in mind was, this is something to enhance the video gaming experience first and foremost, and then secondly, to act as a way of controlling your home multimedia, your home theater, your music file server, and so on, to act as a more user-friendly front end to that. I don't know if Microsoft anticipated, how the hundreds and thousands of ways that people would want to adapt it to other applications, but within a day or two of the product hitting the store shelves, people were already doing that. The APIs, they figured out the APIs, they figured out how to plug it into things other than the Kinect, a PC, a Beagle board, a Roomba robot, or what have you, so that they could try out their own ideas. And now I've heard Microsoft is planning to release an SDK to kind of more actively enable developers to make use of the Kinect in Vision type applications. Meanwhile, since you mentioned open source, there's a really very sophisticated open source computer vision software library called OpenCV. And OpenCV now works with the Kinect. So you can put OpenCV on your PC, plug the Kinect in, and use the two together to quickly prototype vision applications.
Wow, this is something I got to start playing around with. Let's get back to embedded computer vision, and particularly the Alliance.
Yeah.
Talk a little bit about the kind of things, the kind of specifications you think need to be fomented by this kind of movement to really sort of get this part of the electronics market going.
Sure. Well, I think the first thing is just awareness. There are a few industries where computer vision's been used for a long time. But in most electronic equipment companies, it's not a technology that people are familiar with or have particularly been thinking about, gosh, how can we use this in our systems? The Kinect has actually done a lot to raise the awareness, not only in the public in general, but among embedded systems designers about what's possible with computer vision. But there's more of that that's required, just to get people thinking about, hey, what can I do? If I can put computer vision into my product, what can I do? Secondly, the practical know-how. How can I do it? So I want to put gesture-based user interface or face recognition or what have you into my product. How do I go about doing that? Where do I find the algorithms? What sort of processing power do I need? And so forth. There's a ton of information on computer vision out there on the web. That's the good news. The bad news is 99% of it is very theoretical, mostly academic work. Conference papers dense with multivariable calculus. That is a valuable foundation for the field, but it's not, generally speaking, a practical starting point for an engineer in industry. The engineer in industry wants, give me block diagrams, give me example code, reference designs, case studies, and so on, so I can understand how this stuff works. Don't make me take a PhD in computer vision before I can start on my design. That gap is the second thing that we're working on after raising awareness, is filling in this void of practical technical know-how, not the theoretical underpinnings, but the nuts and bolts about processors, about algorithms, software tools, programming languages, development platforms, reference designs. So that's going to be our initial focus, is raising awareness and providing practical technical education for system and chip design engineers who want to think about putting vision capabilities into their products. Beyond that, we'll see where the Alliance members want to go. Standards is one thing that we've been hearing from some of the members. They think there's a need for technology standards to help the field develop. Maybe the Alliance will get involved in that. Other ways that we might be able to help provide easily accessible development infrastructure, example applications, for example, low-cost development kits. Those may be other ways that we can help drive the adoption of the technology or enable it.
And who's involved right now in the Alliance?
There are 16 companies so far. The idea originated with BDTI, Xilinx, and IMS Research, which is a market research firm. And we've had 13 other companies join us. Maybe the best thing for me to do is if I can just bring up my, of course my computer decided to turn off.
To go sleep.
Let me see if I can navigate here to my member slide. Let's see, so we'll go back and then We'll scroll, nope, other way. There we go.
There it is.
So there's my member slide. So that's the, whoops.
Stay up.
Unintentional gesture. So that's
ADI, SIVA,
initial
XMOS,
set of 16
NI.
member companies.
Wow, that's a nice lineup. Very nice lineup. All right, well, thanks for telling us about that, and that's a fantastic demo. Excellent food for thought. Are you going to be at ESC Boston by any chance?
I'm hoping to be.
Okay.
Should I bring another demo?
Absolutely.
Okay, that'll be fun.
Let's keep pushing it ahead.
Look forward to it.
Jeff Bier from BDTI, thanks very much.